Have you ever stopped mid-bite into a slice of pizza and wondered where that rich, tangy red sauce came from? Not the store, not the kitchen. I mean, really, how does a humble tomato go from dirt to jar to your dinner plate? Well, today you're about to find out. We're diving into the world of modern farming, robotic harvesters, laser precision scanners, and food-grade mega factories. This isn't just about sauce, it's about scale, technology, and taste. You'll witness machines that sort tomatoes by color faster than your eyes can blink. You'll see how timing, temperature, and texture are engineered to perfection. And you'll discover the secrets that turn millions of pounds of raw fruit into one of the most beloved ingredients on earth. This is the untold journey of tomato sauce from seed to supermarket shelf. So buckle up. What you're about to see will change the way you look at food forever. Let's begin. From seed to field, how tomato farming got smarter. Let's rewind to the beginning. Before the sauce, before the harvesters, before the machines even touched a tomato. It all starts in a greenhouse and with a single seed. Inside modern greenhouses, trays filled with nutrient-rich substrate are carefully seeded with precision tools. But this isn't like the old days of tossing seeds into rows and hoping for the best. Today's tomato farming begins with data, moisture controls, and calibrated light exposure. In places like Central Valley, California, where water is gold and labor is scarce, growers use automated seeding machines that can plant thousands of seeds per hour with pinpoint depth and spacing. These machines aren't just fast, they're consistent. And consistency is everything when you're prepping for a multi-million-pound harvest. Once these young sprouts reach about 8 to 12 inches tall, they're ready for the field. But here's the twist, they're not planted by hand. They're transplanted by a beast of a machine, the mechanical transplanter. Rolling down long beds like a mobile assembly line, these machines plug seedlings into soil at machine-precise intervals. Now, here's a story for you. In 2017, a third-generation farmer in Yolo County switched from manual transplanting to a GPS-guided transplanter. That one decision cut his labor costs in half and increased his yield by 18%, just because the spacing was more uniform, more air, more sun, fewer diseases. That's the kind of smart farming that changes the game. But even with automation, mistakes still happen. A common one. Overwatering right after transplanting. It might feel like giving the plants a nice welcome drink, but it actually weakens the root system and leads to fungal outbreaks. Lesson learned. Let the roots surge. Let them anchor. Let them fight a little. Resilient roots grow stronger plants. And here's another modern twist, soil sensors and IoT systems. Some growers now use real-time data to monitor soil temperature, pH, and nutrient levels right from a mobile dashboard. Imagine your tomato plants texting you, "Hey boss, we're low on potassium today." That's not the future, that's now. From seed to field, the story of tomato farming has shifted from manual guesswork to precise, repeatable, machine-driven mastery. But smart planting is only half the battle, because knowing when to harvest, that's where the real timing game begins. Up next, how farmers read the signs of ripeness, stop irrigation at just the right moment, and unleash a mechanical army to gather the perfect fruit. Stay with me, you haven't seen anything yet. 2. Timing is everything, how farmers know exactly when to harvest. Here's the truth about tomatoes. My friend, you can plant them perfectly, water them just right, but if you harvest too early or too late, you've just ruined months of work. Because in tomato farming, timing is everything. So how do seasoned growers know exactly when it's go time? They look for a silent signal, when 80 to 90% of the fruit on each plant turns a uniform deep red, not orange, not streaked, red, consistent, confident. This isn't just about color, it's about sugar content, pH balance, and pulp density. Because industrial tomato sauce doesn't just need flavor, it needs structure. A watery tomato means a runny sauce, and nobody wants soggy spaghetti. But there's another secret move the pros make. They stop watering the fields 2 to 3 weeks before harvest. Sounds risky, right? Actually, it's genius. By cutting irrigation, the plant focuses all its energy inward, concentrating flavor, reducing water weight, and firming the pulp. It's like nature's own reduction sauce. More taste, less waste. Real-life example. Out in Stanislaus County, California, farmer Bill Franco learned that lesson the hard way. One year, he delayed cutting irrigation by a week just to be safe. Big mistake. When the harvest came, his tomatoes were beautiful, but the processing plant rejected 12% of his load for being too soft. Lesson in tomato farming: too safe can be costly. Let's talk ripeness. Underripe tomatoes, your shower too much acid. Sour, thin sauce. Overripe tomatoes, your shower soft, watery, and prone to bruising during machine harvest. The margin for error, just a few days. That's why many modern farms now use drone surveillance, thermal imaging, and AI-driven crop forecasting models. These tools measure canopy color, temperature, stress, even chlorophyll levels, all to pinpoint the exact day to hit the field. New growers often rely on visual inspection alone. Here's the trap: tomatoes near the edge of the field ripen faster than the ones deep inside. If you only scout the perimeter, you could be weeks off the mark. Smart growers walk rows, check random samples, and use digital color meters, not just eyeballs. Because in the world of large-scale harvesting, one wrong decision costs thousands of dollars and weeks of regret. But when the timing is perfect, when the color's just right, the fields are dry, and the pulp is dense, that's when the mechanical giants roll in. Steel behemoths designed not just to pick, but to scan, sort, and select in real time, at full speed, across acres of ripened glory. Coming up next, you'll meet the factories on wheels that changed everything. We're talking industrial harvesters so advanced, they could teach a class at MIT. Get ready, because the machines are about to take over. 3. Harvesting giants, the machines that work like mobile factories. Now the stage is set. The fields are dry. The tomatoes are plump, red, and waiting. And then they arrive. Not men with baskets, not trucks with crates. Steel titans, the harvesting giants. These aren't tractors. They're factories on wheels engineered to plow through rows of tomato plants and process tons per hour with surgical precision. Each of these machines can harvest 2 full rows at once, using rotating tines that lift entire plants up off the ground, fruit, vines, dirt, and all. But here's where the magic happens. Inside the belly of the beast, the machine separates the gold from the garbage. First, a set of shaking conveyors loosens the tomatoes from the vines. Then, a cyclone of fans and rollers strips away leaves, stems, and debris. And finally, the crown jewel, an onboard optical sorting system powered by high-speed cameras and color sensors. These sensors don't just see red. They analyze each fruit's hue, size, texture, and light refraction in real time. If a tomato's too green, too bruised, or too soft, bam, a mechanical finger taps it out, right off the line. All of this happens at speeds the human eye can't even follow. Real-life example. In the heart of San Joaquin Valley, one tomato operation upgraded to a harvester with AI-driven defect rejection. The result: waste dropped by 30% and labor costs cut in half. That's not just efficiency, that's survival in today's ag economy. Common mistake and insight. But even these machines have limits. Too wet, the ground gets muddy, tires sink, and harvest slows. Too hot, the fruit softens under the sun, gets crushed during transport. Too late, overripe tomatoes leak juice and reduce pulp quality. Lesson harvest windows are narrow, and once you roll the machines, there's no hitting undo. That's why skilled operators monitor field moisture, machine settings, and bin capacity by the second. A small tweak to shaker speed or fan velocity can make or break an entire load. Once sorted, the tomatoes flow onto a conveyor belt and are dropped gently into massive transport bins. Each one holds up to 300,000 tomatoes. And when full, they're lifted onto waiting trucks, each hauling 22 tons, headed straight to the processing plant. There's no cold storage, no time to spare. This crop is alive, and it's moving. Think about it. Just hours ago, these tomatoes were soaking in sunlight. Now they're traveling in bulk across highways, ready for the next transformation. But what happens once they arrive at the factory? What kind of system can clean, inspect, and prepare tens of millions of tomatoes without damaging a single one? Coming up next, we're going inside the wash line where air, water, and science team up to handle fruit like glass. Stay with me, this ride is just heating up. 4. The cleanest fruit in the world. Why washing tomatoes is a science? They've survived the sun. They've braved the blades of the harvesters. They've made the journey 22 tons at a time from dusty fields to the factory gates. But before a single tomato is cooked, crushed, or canned, it must first pass through one of the most delicate and critical stages in the entire process. The wash line. At first glance, it looks simple. A giant stream of tomatoes rolling into long steel troughs filled with water. But don't be fooled. This is no bath, it's a precisely engineered cleansing system. First, tomatoes are gently unloaded into flume channels, narrow water lanes designed to float the fruit, not drown it. Why? Because tomatoes bruise easily, and bruises, they show up in the sauce as dark flecks and off flavors. Water cushions the impact, protecting both skin and structure. A bruised tomato at this point is a lost sale. 5. From raw to rich, the transformation into sauce. All right, the tomatoes are clean. They're flawless, floating down the line like little red soldiers reporting for duty. But now it's time for the real transformation. From raw fruit to the rich, velvety sauce that coats your pasta, tops your pizza, and fuels comfort food traditions around the world. This is where agriculture meets culinary engineering, and it's one of the most beautiful and precise parts of the journey. The clean tomatoes are sorted by their final purpose. Some are destined for whole or diced packing. Others will be pureed, seasoned, and slow cooked into the sauce we all know and love. But no matter the final product, one thing's for sure: the heat is coming. There are 3 primary cooking systems used in large-scale tomato processing. Steam tunnels, perfect for whole tomatoes. The heat loosens the skin without damaging the flesh. Hot break systems for sauces and pastes. Tomatoes are rapidly heated to around 100 degrees or 212 degrees to preserve pectin and lock in structure. Cold break systems, used when a lighter, fresher flavor is desired, typically for juice or soup bases. Each method has trade-offs. Hot break gives you thickness, cold break gives you brightness. Smart processors know when to use what because every product line has a different soul. Real-life example. In 2019, a plant in Sacramento made the mistake of applying cold break methods to a batch meant for pizza sauce. The result: runny, watery sauce, flavorful but unusable for commercial clients. They lost 2 contracts worth over $1,000 in just one season. Lesson: know your customer, know your chemistry. Now, let's talk puree. Tomatoes headed for sauce are pumped into high-speed blenders equipped with razor-sharp stainless steel blades that slice through seeds, skin, and pulp, creating a silky red base. But hold up, sauce isn't just blended tomatoes. This is where the cooking tanks come in massive stainless steel vats, some as large as a school bus, fitted with steam jackets and constant motion paddles. Inside, the puree is slowly brought up to temperature. And just like Grandma used to do, seasoning is everything. Industrial-scale recipes often include garlic, onion, olive oil, salt, sugar, cinnamon, basil, oregano, maybe even a hint of black pepper or red chili depending on the flavor profile. These aren't just dumped in, they're metered with precision based on weight, pH, and viscosity readings taken throughout the cook cycle. In other words, this is flavor engineered. Common mistaken lesson. Here's where many new processors mess up. Rushing the cook time. Trying to shave an hour off to meet quotas. That's how you scorch the bottom of the tank, leaving burnt flavor in an entire 8-ton batch. The sauce must be stirred slowly, evenly sometimes for 2 to 4 hours, until it reaches the perfect consistency, sheen, and aroma. Veteran operators can smell the difference. They'll tell you if it smells like Sunday dinner, you're doing it right. When I visited a plant in Loden Rush, California, I met an older technician named Raul, worked there 31 years. He told me, the machines may cook it, but we're the ones who taste it into perfection. He still dips a spoon in every 20 minutes, still trusts his nose over the numbers. That, my friend, is the soul of the process. So now the sauce is thick, fragrant, and ready. But it's not done yet, because a sauce this perfect needs to be protected, stored, preserved, sealed like treasure. And when you're filling 1,000 containers a minute, you better believe the packaging game is a science of its own. Coming up next, we head into the lightning-fast world of cans, jars, lids, and vacuum seals where every drop of sauce is locked tight for freshness. Don't blink. It's about to get fast, loud, and incredibly precise. 6. Sealed fresh, how packaging ensures shelf life and safety. All right, the sauce is done. Rich, velvety, packed with flavor. You'd think the hard part is over. But here's the twist. If you don't package that sauce right, it won't last a week, let alone a year. And every drop of effort, every harvest, every recipe, gone to waste. Packaging isn't just about putting sauce in a jar. It's a full-blown precision operation where heat, pressure, vacuum, and timing all work together to lock in freshness and keep danger out. Because once tomatoes are cooked, they're vulnerable, exposed, and bacteria. They love a warm, moist environment. So how do processors fight back? Let's break it down. The sauce fresh off the cooking line is pumped into holding tanks that keep it hot and sterile. From there, it enters automated filler machines that dispense exact quantities down to the gram into tin cans, glass jars, flexible pouches for food service or single-use packs. Each filler line is tuned for viscosity, flow rate, and temperature because if it moves too fast, you get splatter. Too slow, the sauce cools and risks microbial exposure. But it doesn't stop there. After filling, each container is sealed immediately. Cans get crimped shut with double seamers, forming an airtight lock. Jars, they're vacuum sealed while still hot, pulling the lid down tight as they cool. Pouches are heat welded by robotic arms that clamp, seal, and eject in under a second. Some of the top-of-the-line machines, they can seal 1-200 units per minute. That's 20 every second. You blink, you miss 40. Real-life example. At a plant in Stockton, an over-tightened vacuum lid caused a batch of jars to implode during cooling glass shards everywhere. Turns out, a technician had recalibrated pressure settings after maintenance, but forgot to test at production scale. The damaged 36,000 jars destroyed in under 40 minutes. Lesson: precision isn't optional, it's everything. Comparison permagchering. Now let's talk formats. Tin cans, durable, cheap, and recyclable, great for long-haul export. Glass jars, premium look, reusable, but heavy and fragile. Pouches lightweight, space-saving, but need specialized handling. Each has a role and a market. Ever notice how restaurant-grade sauces come in giant pouches? That's efficiency. Meanwhile, your grandma's pantry, probably full of glass jars with gingham lids. Different customer, different packaging logic. Common mistaken insight. A rookie mistake. Skipping the hot fill window. If the sauce cools even a few degrees below safe fill temp, usually around 185 degrees, the vacuum seal won't take. That leads to bloated cans, pop-top jars, and worst-case botulism risk. Smart plants have infrared scanners and inline thermometers to flag any under-temp containers before they hit the sealer. Years ago, a retired Navy machinist named Carl told me, "You don't seal food, you seal trust." He was right. Because whether it's spaghetti night with the grandkids or a pantry stock for winter, you expect that jar to be safe, fresh, and flavorful months down the line. That's what all this machinery is protecting. So now, the sauce is sealed. The harvest has become a product shelf-stable, road-ready, and built to feed millions. But there's one more piece to this puzzle. Because this isn't just about factories and machines. It's about the entire chain, from seed to spoon efficiency, tradition, and modern engineering working together. Up next, we wrap it all up, how the sauce industry reflects the future of food, the lessons we've learned, and why this red liquid still matters more than ever. You won't want to miss it. Seven, from factory to fork lessons in efficiency, flavor, and global impact. And just like that, a tomato's journey is complete. From seed to soil, sun to steam, conveyor to can, that simple red fruit has traveled farther, faster, and with more precision than most people realize. But this isn't just a story about sauce. This is a masterclass in modern efficiency, a glimpse into how the world feeds itself at scale, and it all ends where it began, at your table. Every year, over 200 million tons of tomatoes are produced globally. Of that, around 25% go into industrial processing, becoming sauces, pastes, purees, powders, each designed, engineered, and tailored to meet different culinary needs across cultures and continents. That red sauce on your pasta in New York, it may have started in a California field. The base for shakshuka in Tel Aviv could have come from a Turkish greenhouse. It's all connected. What we've seen isn't just a food process. It's a global operation of precision, partnership, and trust. Machines harvest thousands of tons per day. AI sorts fruit in milliseconds. Sensors monitor temperature, pH, and flow like a heartbeat. And behind every blinking light and buzzing motor, a human decision, a lesson learned, a story remembered. Real-life example, global scale. Did you know that in Italy's Parma region, where traditional passata is king, industrial processors still use high-tech cold break systems not to replace tradition, but to preserve it? Or that in Japan, tomato processors have developed low-acid hybrid sauces specifically for elderly digestion, addressing a growing senior population. Food tech isn't just about faster, it's about smarter, more inclusive, and more adaptable. Common pitfall, the efficient versus authentic trap. Some folks still believe that industrial food means less authentic, that machines rob food of its soul. But here's the truth. Without these systems, the scale we need to feed 8 billion people just wouldn't be possible. Yes, handmade sauces have charm. Yes, small batch methods have their place. But when efficiency meets careful design, intelligent monitoring, and culinary respect, you get something remarkable. Safe, affordable, high-quality food for millions. I've walked the fields. I've stood beside the roar of the harvesters. I've felt the floor vibrate under the weight of 40-ton trucks unloading sauce-ready fruit. But the moment that still gets me, watching a grandparent stir store-bought tomato sauce into a pot of noodles and hearing a kid at the table say, "This tastes just like Nona's." That right there is the power of modern food engineering done right. It connects people. It keeps tradition alive. It builds bridges between field and family. So the next time you crack open a can of tomato sauce, take a second to appreciate the science, sweat, steel, and soul behind it. Because that sauce, it isn't just cooked. It's engineered, harvested, washed, scanned, simmered, and sealed with the wisdom of generations and the precision of machines. If you've enjoyed this journey from dirt to dinner table, give this video a thumbs up. Share it with someone who loves food as much as you do, and drop a comment telling us what's your favorite way to use tomato sauce. And don't forget subscribe for more behind-the-scenes looks at the machines and minds shaping the future of food. Thanks for watching, and as always, stay curious.